Hello everyone. Here I am going to review the central limit theorem and its application, and I'm planning to do it in two parts. And this review I'm going to pick up some questions from my stat lab and review those questions. So let's go. Question number 1. Here the question is asking you to draw all possible samples of size 2 from the population of size 4. So the population values is 4, 5, 6, 7. This is your population from which you are going to draw the sample of size 2. So here is how I'm going to do it. 4, 5, 6, 7, 4, 5, 6, 7. So I'm looking for the average of each pair. So I'm going to say equal to 4 plus, then I'm going to give the cell reference divided by 2. So I got the average of 4 and 4. Now I'm going to drop and drag and drop equal to, I'm going to use 5 plus cell reference 4 divided by 2, 4.5, and then I'm going to drag and drop. Next one equal to 6 plus 4 cell reference divided by 2, then I'm going to drag and drop. Last one equal to 7 plus cell reference, 7 plus cell reference divided by 2. That means 7 plus 4 divided by 2 is 5.5, and here it is. So I got all the averages. Now let me verify 4, 4.5, 5, 5.5, etc. So in my question, when I go there, it is 4 is 4, 4.5, and 5 is 4.4, 4 and 6 is 5, 4 and 7 is 5.5, and so on. All right, so I got all of those numbers. So you can fill out as many as you want, but I just did 2. Okay, so the question number 2, well, section B. If the sample of size n equal to 2 measurement is randomly selected from the population, what is the probability that a specific sample will be selected? Well, specific sample, that means one specific sample will be selected. There are 16 observations, so the probability of one particular observation is 1/16, right? Obviously 1/16. Now the C part is saying complete the sampling distribution table. Type the X bar values in the ascending order. So these are the X bar values, and then corresponding probabilities. Very simple. You go to the table and then see 16 observations. How many times 4 occurred? Once. So the probability is 1/16. 1/16. For 4.5, how many times it occurred? Twice. 2/16 is 1/8. 2/16 1/8. How many times 5 occurred? 1, 2, 3. 3 times. So 3/16, 3/16, and so on. You're going to complete this distribution table. And obviously it's a symmetric distribution, so in the graph, your bar graph, you're going to see the symmetric distribution. That is the distribution of X bar. Okay, good. Question number 2. Well, this is basically from the central limit theorem that I've discussed already in the link to that I have provided in the comment section. But it's just like this. Mu is given, sigma is given, n is given. So the standard errors of the variance of the sample mean is this. And I have obtained it by using these two numbers. That means sigma over square root of n. N is this column, F15 column, G15 column rather. Okay, so be very careful. If the sigma is given, you don't need to take the square root of the numerator. If the variance is given, you need to, okay? All right, next question. Question number 3. Well, this is my link to, look at the comment box, and you click at the link to, I have a detailed description of the procedures. This is also linked to. This is confidence interval. This is link 3. I have given the detailed steps of that. This is also link 3. 17. Now, this is also link 3, but I'm going to show you the steps here because the sample data is given instead of giving you the estimates. So sample data 975,438. 975,438. I computed the mean and the standard deviation. For the mean, I just use the formula average of this, or you can add them and divide by 6. You will get the same number. And the standard deviation, I use this formula. So I got the standard deviation. So I wrote down the standard deviation here. S over square root of n is the standard error of the mean. And then T alpha over 2 I obtained by using TINV 0.1 degrees of freedom 5, because I have 6 observation. It is 5 degrees of freedom, and 0.1 because it is 90% confidence interval. I do not need to divide by 2 because for distribution the program is taking care of that. Now the error, this part is called error. So this part is the error. So I get it by just multiplying this with that. Multiplying this with that, so I got the error. Now it is very simple. Add with the x bar and subtract with the x bar. What is the x bar? 6 is the x bar. So 6 plus this is the upper limit. 6 minus this is the lower limit. So 7.95 and 4.05 are the limit. 7.95, 4.05, okay? So the next question, number 8. Well, this is a theoretical question, study binomial distribution, and you will see the right answer is C. There is also a theoretical question. The question asking you to determine what is the population. Well, they are serving the adults, so adult is the population. They have a sample of size 40 adults, so that is the sample, and so on. So study that part on the sampling theory. Now this one asks you to construct the 90% confidence interval of a proportion. Basically, there is a group of 40 people, and out of those 40, 16 people dropped out. So construct the rate of drop rate and construct a 90% confidence interval for the drop rate. Okay, 16 over 40. So let's go back to the Excel. Number 10. So n equal to 40. So drop is 16. So p hat is 16 over 40. Very simple. Z alpha 90% confidence interval I obtained by norms INV 0.1 over 2. Remember, normal distribution you need to divide by 2. For t distribution you do not. I computed sigma x bar by using this formula. You can see I3 is this I3, p hat 1 minus p hat over k3 is n. Okay, now I computed the error. Error is this times that. If you look at this times that. And now I just add and subtract from p. So when I add and subtract, because this is negative, so that means adding means you're subtracting means you're adding. So 5.27 and 2.73. Those are the numbers for the confidence interval. 5.27, 2.73. Okay, number 11. Okay, in this case, this is slightly different. I did not discuss that in any of my previous discussion. In this case, error limit is given to you for 95% confidence interval. If you know the sigma square rather, how many sample observations you have to take. So let's go back to the Excel page. So this is called error. If you look at the confidence interval, this part is the error, okay? So error is given to you. I just rewrote it, and then by algebraic operation you can say n is equal to this. This is the formula. Main thing you need to pay attention here that you need to use sigma, not the sigma square. So I computed sigma by taking the square root of this. So this is here. And then I just use this formula. And if you look at the formula, you will see I18 is the z value right here. And then J17 is the sigma value right here, and divided by E, error is 0.27. So two things that you need to do here, need to calculate the norms INV 0.05 by 2 because it's 95% confidence interval. So 95% confidence interval, let's see. 95% confidence interval. Okay, good. So, and then I got this number, which is 343, basically, round up. 343. It's right here, 343. Okay? So, this is the first part, and then I'm going to prepare 12, 13, 14 for the second part. Thank you.